just get started?
Yes, we can get started.
Good evening. My name is Scott Rodman. I'm part of the Lincoln Sea-Free Group, which is a subgroup of the Green Energy Committee. And we're happy to have Tim Locke with us tonight from Opal Architecture in Maine, and to talk about the important issues of in our Getting to Zero series of embodied carbon. And Tim will talk about a bunch of things along those lines, and we'll have some questions at the end. But the goal is to really demystify some of the carbon elements that are talked about so much in society today that need a little more information. And we're excited to have Tim with us. Tim is a well-known architect who has been practicing in New York and in Maine, and as part of Opal Architecture, which has a great history of some innovative thoughts and so forth in a whole bunch of building types. And Tim also serves on the Biden White House's advisory committee to deal with look at the definitional elements for carbon and the ways to approach it. And so I want to also mention that we're doing this is part of the latest in our series, but we have recorded presentations up, including the following things you'll see up on the screen: using a FLIR camera, retrofitting the home envelope windows, solar heat pumps, retrofitting a modern house, builders' perspectives, incentives, demand response, and we will continue to put those out. That's just the ones we've done recently. We've done a pile of them in the past. So please visit the site, and those recorded videos are at lincolngreenenergy.org. And so without further taking my time for allow Tim to start, I'd like to welcome Tim Locke, and we look forward to your talk and presentation.
Thanks a lot, Scott. Thanks everybody for having me here tonight. It's always exciting to meet a new group of people that are that care a lot about some of the issues that we certainly care a lot about in our practice up in Maine, and that are looking to educate themselves on how we can be impactful in a positive manner. I'm going to go ahead and share my screen here, and we'll get going. Let me hide all of the random junk that Zoom gives us in just a second. Okay. So can everybody see the screen okay?
Yes.
Wonderful. I think it's important to start when we're thinking about embodied carbon to think about what we mean when we talk about getting to zero, and when we're thinking about buildings, what we mean by embodied carbon versus operational carbon. We'll talk about that a lot tonight. We've started to gravitate around this just notion of whole life emissions in buildings, that we know enough now about the way carbon is stored and used in our resources, resource extraction for materials, and also resource extraction of fossil fuels and other prime movers for energy, to really stop separating these things into multiple categories and thinking about really just a whole life emissions in buildings. And when we think about that, I think I always really like thinking about this quote. It's kind of a real mantra of mine, that the ultimate hidden truth of the world is that it's something that we make and can just as easily be made differently, because we're talking about making things. We're talking about designing first and then executing that design that extracts a lot of resources, has a lot of impact. And how could we think about that impact as something that could potentially be done differently? And what that means for us at Opal is just a really simple statement and kind of North Star. What if buildings improved our world instead of detracted from it? We think about that as our kind of unique human ecology, right? That these buildings are really tools that allow us to live and proliferate, human species all over the planet. Certainly in our region, it wouldn't be possible for us to live in this region without buildings. We need them for shelter, we need them to work in, we need them to live in, etc. And so there are kind of a necessary interactive element between us and our environment. So whenever we're approaching a building, the first thing that we always want to do is think about climate. And in this case, I don't mean climate change or climate change impact, and we certainly eventually mean that. But first thing is just like literally what climate are we trying to use this ecological tool in? And so I like to, we like to start these types of talks by always identifying ourselves and introducing ourselves. Well, I'm going to introduce our location, our unique climate and geography. Belfast, Maine, it's a cold climate, zone 6A. We have a lot of heating degree days. We have almost no cooling degree days. We have a fair amount of solar radiation, pretty similar to where you are in Massachusetts. And we have a very, actually very clean energy grid in Maine, only 0.2 kilograms of CO2 per kilowatt hour. And so in any project, any design, any sort of advocacy that we're doing, I'm always starting with climate, like where are we? So we know what our impacts will be going forward. And that's always a great place to start. And for us, that was kind of the founding principle of the practice. And we started in 2008. And we, at that point, we're really only thinking about operational emissions. And so for us, Passive House made a lot of sense because it dealt with that 7,800 heating degree days really, really easily. We were able to suddenly make buildings that were unlivable livable in that climate. We were able to reduce people's energy bills. We were able to make institutions that had a tough time meeting their operational budgets solvent over a long period of time. Passive House was really a trigger to, if thought of appropriately as a design problem, unlock the potential for buildings across our area. And that led to a lot of really amazing firsts for us. This is the first Passive House certified in Maine. It was only the 12th overall. This is our first project that was done through venture capital back when we were still called Geologic. But we also, for instance, did the first CLT project in the entire region. This is a tiny little CLT collection of houses that were brought over to Vinyl Haven on a ferry. We call this project Little House on the Ferry. This was the first Passive House certified laboratory in all of North America, the Warren Woods Ecological Field Station for the University of Chicago. This was in 2014. Still the only Passive House certified laboratory in North America. We kind of got used to taking these kind of wild swings and big risks up here because there wasn't a lot of people to tell us no, or that was a silly idea. And you'll see that as a theme throughout our practice, not just our architecture practice, but our sibling companies as well. Here, it was the first project to get into all wood construction, so solid cross-laminated timber panels with all wood fiber insulation. This was a predecessor to Timber HP, which is now a wood fiber insulation company. I see we have Scott Johnson on the call, which is great, from Timber HP. And even other types of buildings that were about unique ecological conditions. Here's a project that was a gallery project that actually was reusing a historic timber frame. So applying Passive House even in a reuse setting and thinking about circular materials before anybody was even using that type of definition for simply reusing a historic timber frame. We're able to work in like really unique and beautiful ecological landscapes. This is a project in Mid-Coast, Maine, just outside of Camden. This is a project on North Haven, just north of Vinyl Haven. Recent award winner, this house here, and then much larger scales as well. Quite, in our history, quite quickly, institutions are realizing the potential of thinking about positive impacts across much larger designs. This is the Ecology Atlantic Center for Human Ecology, which notably just won last Friday evening an AIA National Design Award, which is a first for the state and certainly a first for us. And it was really, really exciting to be acknowledged at the national level. And we tracked that kind of operational emissions impact. And I saw that in some of your previous talks in this lecture series have talked a lot about energy reduction, Passive House principles, things like that. We've been tracking that through our entire history of the practice. And in this green line, you see all the projects that exceeded the energy reduction goals that we'd set out for them across our entire portfolio. And we continue to do that. We do this through a reporting structure that our membership organization, the American Institute of Architects, sets up for all of its members. It's elective, it's free. You can use it to catalog all your projects. You can also use it to start to compare how you're doing against other firms. And we're really excited to see that for 5 years running, we're one of under 20 firms nationally that's exceeded the energy reduction goals set by AIA to meet our overall 2030 targets of drawing down to zero operational energy. And so that was like the first decade of our practice. But as we were doing that, we started to kind of really assess specifically, how limited was that thinking? Like, were we really capturing impacts effectively for buildings? And so these are just some really basic kind of systems dynamics diagrams that we started putting together that for that first 10 years, even though we were doing some very, very progressive, very advanced, very ecological design and architecture, we had a fairly limited system that we were looking at. So we're looking at the building itself as its four walls. You had energy coming in, waste and heat and emissions coming out. And that was the boundary of the mental model that we were applying to our designs. And this is really early days of thinking about embodied carbon, and people are starting to come out with some tools called life cycle assessment tools. It was about 2017, and we said, maybe we need to consider these resources that go into these buildings as well as the energy, and just see what our impacts truly are when we think about that. So we expanded that system boundary to think about the inputs of materials and the outputs of waste and byproducts at the end of the life cycle or during construction. So we started doing life cycle analysis on the materials alongside energy modeling at the passive house level on the energy systems that the buildings used. And after a few years of doing that, we realized that really a full recognition that our projects participate in a larger system was required. It wasn't just those resources from energy and materials themselves, but also water, the local site ecology, and the stakeholders themselves, the people that were going to occupy the building and their community health, all had to be inputs and all had potential byproducts, that there was impacts that came from those. And so we decided to have this like radical decision that we were going to create our own framework to measure all of this. So we developed that over 2 years. We finished that work last spring. And now we use this framework on all of our projects. It's really trying to take a holistic look at all of these systems and how they impact. We're trying to do that at the same time as we're making great design, because this is this great study that came out in Scientific American last May that did a research focus group, and was trying to get to the bottom of what interventions actually motivate people to change their behavior. This could be on climate. That was specific to the questions that they asked the research group, but it could really be about anything. And we'd been great advocates and educators for the entire history of our practice, but we were surprised to see, although maybe not shocked, that education is actually the least motivating intervention, that throwing a bunch of data at people about how our impacts are going to affect us doesn't really move people that well. What does move people is designing beautiful things that do the impact effectively, that make positive change that they can see, relate to specifically, and emulate potentially, right? So that puts us in a great position as designers, because we're making things, we're designing things, they're getting built. If those things can simultaneously have positive impact and be beautiful and be an agent for change for the people that occupy them, then you have a great example that somebody can emulate, instead of just dumping a bunch of data on their head. So we're trying to do this all simultaneously. And what that meant for us is that we really needed to expand the umbrella of our practice, right? And this happened over the course of many years. But we took what was essentially an architectural design firm and expanded it into 3 separate companies, now fully separated from each other and operating independently, although we all have, myself and my 2 partners have some tendrils in all of them. There's Opal, which still does architectural design, but also does holistic ecological consulting. It's kind of the hat I'm wearing with you tonight over here. We have Timber HP, which, starting about 5 to 7 years ago on a whim between my business partner, Matt, and his collaborator, Josh Henry, started a wood fiber insulation factory. So it's kind of crazy, like architects deciding to do this, but that's now fully operational and is making insulation out of residual wood byproducts, lumber industry byproducts in central Maine. And then lastly, Opal Build, which is a mass timber component fabrication company, because we're seeing it's not enough to identify what resources have potential positive impact, but we have to allow for the potential for our clients, whether they're coming from Opal or coming from somewhere else, like other architects, to actually access those materials and be able to purchase them and install them in their buildings. So now we're looking at a more holistic approach where we can actually provide that social comparison, that artist solution to the problem. So I'm going to go through each of them quickly, and then we'll look at a couple of case studies at the end. Starting with our building and ecological consulting and advocacy. This is the branch of those kind of expanded umbrella that I certainly am most involved with. It's the part that I lead, and I lead a lot of the research for it as well. And it's not just me, though. We have a great squad. We call it our building ecology squad that helps me put together all this research. And it's been really a joy to be able to have that as part of our practice. It scratches an itch for me, but it also really allows us to be kind of dynamic within the space. And it started with this kind of like crazy notion. We had all of these certification criteria. We had LEED, we had Living Building Challenge, we had Passive House Institute, Well Building, and then we had this one client, College Atlantic, had these like super aggressive sustainability goals. And one day I was like, like we really need this like big periodic table so we can sort these. And so I always show this slide because you can't read any of this, and that's deliberate, right? It's impossible to read because there's all these criteria that are listed in all these certifications. And I wanted to sort through and say, which of these actually have any impact whatsoever? And which of these are just elective things that people can do to get points in these certifications and actually don't change the design, don't have any real, positive or negative impact on our ecology. And I wanted to kind of get my head around it. So it's like, let's make this big diagram, put everything out there, and then just start sorting them into categories. So we color coded them in each of these frameworks into our own 5 categories that you saw earlier, those inputs coming into the building. And then what we did was they took that periodic table and then resorted them into our categories. So we have habitable planet, that's about energy and emissions. We have responsible resources, that's about circularity, how we can reuse things and extend the lives of the things that we do need to use. Water availability and quality, another essential part of human life on the planet is access to water. That was an important one to us. Local environmental health, what's their impact on the actual sites that we work on, and then community health. And just sorted everything together and then distilled it down just into those 5 categories and labeled that the dimensions of building ecology, our Opal's dimensions of building ecology, and allowed that to be the framework that kind of guided all of our approach to any project, any practice. And we chose those 5 because it was scaled in the impact of the community affected by the decisions we make in each of the categories. So at the top of the scale, at the global scale, habitable planet, that's about mitigating overall global climate change. So when we're talking about emissions, we're talking about things up in this category. So whether it's energy use, resources extraction, life cycle analysis, those all belong up in here. Directly below that is circular resources. That's about shifting our regional waste streams and inputs away from things that are use and discard to something that's a little bit more reuse focused. Obviously, they affect each other as well. Protected water cycle, you're getting even a little bit tighter in your region. Resilient ecosystems, you're getting down to the neighborhood level. And then the local at the very bottom is the healthy community. That's like literally the people that are going to use the building that you design or build. And the kind of aha moment for me about sorting that in this way is we had so many clients that cared deeply about climate change, that cared deeply about making a positive impact. They didn't understand anything about emissions, carbon, energy. They knew that they needed to do something about it. But what really drew them into sustainability and ecology in buildings was making sure they had healthy space for their occupants. And that could be, say, a school building, or it could be a house, could be anything. and that that human health component was their way into this larger framework. And once they could learn how those things were connected, it really opened up the doors to some really, really positive outcomes and effective solutions. So it's proven to be a really great structure for us, and a really great way to think about a project. We kind of gave our top 3 in each category. We give this to every client and tell them there's a lot of data behind all this that we track. You don't need to think about the data at all. What you need to think about is that we're going to do these top level things in each of these categories for you. We got this. And that takes a lot of research on the back end, but it's been a really effective way to kind of make sure that people understand that they're taken care of when we think about these buildings. Habitable planet's the most important one in these, the most hierarchically most important to the global conditions that we face. And buildings represent a great opportunity here, because about 40% of all global warming potential is from buildings. It's either from the use of buildings and the operational emissions here, or it's from the materials, the embodied emissions. I think the language we use is really important. We would like to start talking about these things instead of talking about physical carbon. We want to talk about emissions, because what we're really concerned about is that CO2 and other equivalent emissions like methane. Less concerned about solid carbon. In fact, solid carbon storage can be a huge positive benefit. So we're trying to transition into language that's more holistic and can capture both. So operational emissions and embodied emissions, and thinking about them together. In buildings, if you can do a positive building, like you're talking about really significant climate change action. Maybe the luckiest thing in my life, given how much I care about this, is to have been an architect, because the lever that we have to pull here on climate action is enormous. And I didn't know that when I got into the field, but over time, I find it to be an incredibly rewarding position to be in and field to be in. So when we're thinking about that in relation to like climate, it has to get quite local. Like what can work in one place doesn't necessarily work in the same way everywhere once you're thinking about total emissions. So we talked about Maine before, but even just as close as you are, 3 hours away from where I'm sitting right now, your conditions are actually quite different. You have considerably less heating degree days where you're sitting in Massachusetts than where I do now. Where I'm sitting, you have many more cooling degree days, so you have more energy used for cooling. And you have about twice as impactful an energy grid. So focusing first on energy in Massachusetts is actually much higher a priority and positive action than in Maine, because if you can reduce the amount of energy used on a dirtier energy grid, you're going to have greater impact in Massachusetts than you would here. And so there's very few practices that are getting that specific, and when they look at carbon and being that, look at emissions and being that targeted based on where they're working. And it's allowed us to create really unique solutions in the different climates that we work. And as we start to think about that and pivot our focus to things like embodied emissions, we need to be really specific about where the priorities are there too. So front and center is concrete and steel. It's the most impactful, negatively impactful material extraction that happens in buildings. It's up to over 30% of all of the emissions that are in the materials in the building. That's, when I talk about emissions there, I mean, how much energy does it take to extract these things from the earth, make them into materials, ship those materials to the site, service the materials when they're in construction and while they're part of the building, and then potentially replace them and demolish them at the end of life. And so we track that on all of the projects that we do. And we're able to quite quickly learn where are our potential instances of impact. And you start to see pretty quickly like where the thing is. Like you're building this very expensive enclosure to allow you to be able to live comfortably wherever you are. And that has a lot of mass, and therefore that's the biggest impact. So the exterior walls and the structure, that drives the bus on all of this. And we assess it across what we call a life cycle assessment. The traditional life cycle assessment involves what's called a cradle to grave assessment when you're talking about a building. So it takes It accounts for everything from when the raw material is extracted from the ground all the way until it's eventually reused and recycled into other materials down the road, if that happens. It also includes operational emissions. And one thing that I think is very confusing for people, and hopefully we can cut through some of that tonight, is this idea that there's the energy you use and then there's the resources. And the resources are the life cycle assessment and the energy is the energy model. It's like, well, actually, the energy model is nested within the life cycle assessment. So this module that we have, this scope of assessment, B6 as we call it, all these categories are arbitrary. They were made up by the original researchers who came up with life cycle assessment at the University of Bath in the UK. Well, this B6, that energy model that we do when we're looking at passive house or any other kind of advanced building performance criteria, is actually part of a life cycle assessment. So if done properly and we do a whole life cycle assessment, it's inclusive of the energy model. And the more we talk about that in our practice, we're talking about things in those terms. It's like, rather than saying there's these two separate things, it's all one thing. The energy use is part of it. It's the biggest part of it, but it's still just part of it. We also like to talk about circularity a lot now because that reuse component can really help reduce our life cycle assessments. That's an area of study that was really pushed by the Ellen MacArthur Foundation. They're really the driving force around how we think about material circularity. But I like to think about it in these really simple terms. Things can be circular when they're very, very similar to each other, to other versions of each other. And the number of units made is a lot of them, right? So the most circular things, the most potential for use is clothing and furniture because it's pretty simple. Humans are all about the same size. And so it's really easy to reuse furniture and clothes. It's really, really hard to reuse boats because they're not very similar to each other and there's very few of them made. Buildings are kind of in the middle. We have a medium amount of them. It can seem like a lot, but they're really different. Like a lot of buildings aren't similar to each other. So part of us thinking about overall building emissions is us thinking really carefully about the way we design so that things can potentially be reused. And when at the end of the life of a building, we can kind of extract material that's beneficial to us to rebuild another building or reuse the building as a whole. And it's becoming more and more part of the kind of progressive thinking around building ecology. And so that adds this dimension to that life cycle analysis. We have to look backwards now. So it's like you're thinking back in time and forward in time from the point in time when you're designing a building right here. So you're thinking about all the materials you could potentially use from a building that might already exist. Maybe it's the building on your site, building down the street, a building that is just being taken to the salvage yard, whatever it is. Like, how do you think about this thing as a circular set of resources that then reduces that raw material supply need right here? So this becomes really a four-dimensional problem, which is super exciting for me. Sometimes can be really annoying for my staff when I continue to ask these questions of people and they're making design decisions, but it's kind of critical to the way we're designing and working now. And that's just about like collapsing this kind of idea of the old building and new building as being separate elements, but trying to combine them together into one set of thinking. And using things from old buildings and new buildings and potentially design in a way that this new building or design could then be reused. So we're not going to talk a lot about water tonight. We're not going to talk about ecosystems or healthy community. They're really interesting topics and then fascinating. These areas of research are less developed than what the subject matter is here tonight, but are definitely part of our framework. And we go through and we measure all this. We're able to produce these fun spider graphs that are unique to our framework for every project and benchmark it. We can measure all the projects that we've done, know what a good score is and what our goals can be. And it's a really important part of making sure we're consistent with that work. And that allows us to do really exciting things like what Scott presented earlier, that it allows us to be leaders in the space. So one of the most exciting things in the last 2 years for me is this work that I've been doing with the Biden-Harris administration, their climate policy office. So this was a connection that I'd made through some of my work at AIA National. I got a call one day from a blocked number and answered it. And it was my now colleague, Heather Clark here, who is the director of building emissions in the Climate Policy Office. And she's like, would you like to get a group together to help me define zero emissions buildings as a national definition? I was like, of course I would. You get a call from the White House, like it can be incredibly motivational. So over the course of last year, we developed, a small cohort of us across several disciplines helped develop this definition. We had a series of meetings at the White House. This is funny enough, it was in the Secretary of War suite. This is this room here. And thankfully there was no shots fired during the meeting, but we were able to go through, colleagues of mine from all over the country, with myself facilitating this group, go through and set with the White House a definition for zero emissions buildings called Part 1. It's called Part 1 now because it only deals with operational emissions. And just last week on Thursday, it was officially announced. There was an article in Bloomberg that came out at the same time as Ali Zaidi presented it at our annual conference at AIA 24 last week to about 5,000 people in the room, and then simulcast to the rest of our membership. It was a really exciting moment after a lot of hard work. And it really boils down to a very simple definition. It's a building that requires a reduction in energy use for both new buildings and retrofits off the most current code. So regardless of what code your state has adopted, you have to go to the most current one and then reduce the amount of energy use from there. It requires zero on-site emissions. That means no fossil fuels on site of any kind. It requires all emissions to be compensated for by renewable energy production on or off site. So that gets you to true zero on operational emissions, on energy use, right? And it's really straightforward, very easy to follow, very easy to measure because zero is easy to measure. Anything that you produce has to be compensated for. The big benefits there, and people always ask this, like, why is it important to have a definition? Well, common language is important. We know that just from communicating with each other in communities and learning from each other. But specifically, it's important because legislation in the US cannot take on specific outcomes unless there's established federal definitions around what those outcomes are. So you can't make legislation on a, let's say, quote unquote, net zero building and base it on LEED or Passive House, because those are private standards that are set differently, they're measured differently, and so you can't use them. You can't create legislation around them. So it's really important in having it as a tool. It also becomes a tool for financing. Any FDIC-backed financial asset needs a federal definition in order to be insurable. And so if you wanted to create a financial asset around the lower risk of a zero emissions building, you need a definition of a zero emission building. It can be easily embedded in sustainable certifications like LEED, International Living Futures Institute, et cetera, as well as federal criteria. So EPA Energy Star will be the vehicle for rolling this out because it's a federal agency. It makes it really easy and everybody knows Energy Star, and it provides a pathway to decarbonize large-scale building asset portfolios if they can point to one specific simple set of rules on how to do this and don't need complicated certifications to get there. But that, of course, only dealt with the operations. And we as architects immediately asked the White House, well, when are we going to get to do that for embodied emissions? And they said, you asked for it, we'll roll right into that. So this year we started to work on that. And that is exceedingly harder. The reason it's harder is because it's very simple to measure zero on energy use. It doesn't take a lot of tools. It doesn't take a lot of actions. It can be expensive depending on what part of the country you're in, but it's very simple. There isn't even consensus on exactly the way to measure whole life emissions. So there I'm talking about all those embodied emissions, right? What we did as our group is we kind of just took a pass at it, tried to wing it, I guess, and we said, we know what the global emissions budget, total emissions budget will be for the entire planet if we want to stay under 2 degrees, right? Based on the Paris Accord. And that was something that's been reported. We could use that number. It's 230 gigatons of carbon dioxide emissions. We knew what the US's budget for that was based on what percentage of that we use. So we got down to 28 gigatons. Then out of that number, we knew what the construction sector in the US traditionally uses. That was 5 gigatons. And from there, based on how much new and retrofit building is done every year, we could distill a actual per meter carbon emissions budget. And that came out to 480 kilograms CO2 per meter squared. We use meters because kilograms could be converted to pounds and feet, but that's generally the international standard for measuring carbon emissions. So we knew we had it. And remember, we also knew, because this group of us knows about whole life assessment, that the energy use had to be part of that. So suddenly part 1 that we'd made with the White House became a subset of part 2 that we're working on now. And sorry, get rid of this. Had a lot of great colleagues work on this with me, but a very small group. This isn't a huge number of people that is able to kind of assess this information. It's a very new field of study, even within design. But great, really excited, passionate people working from all over the country together on Zoom, trying things, coming up with standards. And what we learned about this is that we can't call it zero whole life emissions today. It's almost impossible to do a zero whole life emissions building right now when you assess all those criteria. What we did know was possible is that we could draw down to zero over the next 20 years. That keeps us in line with the 2050 goals. And we set an aggressive target at that 480 and just draw it down progressively, like the reverse hockey stick to an asymptote at 0 over those 20 years, knowing that as people strive to get to there, even if they don't hit absolute 0 on whole life emissions, that close enough draws the building sector down far enough that we're doing better than we'd hoped against in that fight against global warming potential. So it's really exciting work. We're in the middle of it now, and it's really been a pleasure to do that work. And that requires materials to support that change. So Timber HP, as our sibling company making wood fiber in Madison, Maine, is critical to that. We need to make materials that help us draw that down quicker. So materials that store carbon, in this case, I do mean carbon, solid carbon, inside the building and don't release it, are really important. Timber HP is wood fiber insulation made of wood residuals from the lumber industry. It's incredibly important when we get to lower energy use buildings because those have more mass, like we talked about before. And so as we draw down to 0 operational emissions, then embodied becomes much, much more critical. Wood fiber has the ability to store carbon, as I said. So as the tree is growing, it's soaking up carbon dioxide out of the atmosphere. And if you can trap that inside the building in any form, that's going to be a negative in your overall assessment of carbon emissions. And so wood fiber is the only insulation that allows you to kind of show that negative in its manufacturing stage. And again, it's such a great material because it's made with waste. We take round logs in the lumber industry, we cut them into these orthogonal components, and we have a lot of waste from that. Most of those chips used to go to the manufacturing of paper, but as we use less and less paper, wood fiber insulation is a great use study, because really it's just less dense paper. We're just not pressing it as hard. I mean, being overly simplistic there, but that's kind of the way it works, and that we want to entrap air in it to make it have an insulative quality. But it's using the exact same waste, and we have a lot of waste, a lot of lumber waste in the U.S. I love this map because it can just show us the areas that have this potential. We have all of this forestry happening all over the country, and the ability to kind of make use of that waste stream into something positive that can store carbon in a building is truly exciting. Several of these materials are already available. This is an image of the mill in Madison that Timber HP took over and is now producing insulation from. It didn't yet have the great big logo on it yet. That's up there now. So if you come visit, you're going to see a nice big Timber HP logo on the side of this. This was earlier in the construction phase of the project. And again, high performance carbon storing, recyclable, non-toxic, safe, totally circular, in that when it's demolished, it can go right back into that same waste stream. And there's 3 products. There's timber fill, which is a loose fill, can be blown in. There's bat, which is similar to fiberglass or mineral wool bat insulation like rock wool. And then there's the board, which everybody's excited about. That's coming out later. It's coming out soon. That's there to kind of take over for blue and white foam that we typically use on buildings. And it allows us to kind of store, all this carbon inside the building and not emit it. We also, as I mentioned, have Opal Build. Opal Build is this mass timber component fabrication company. So that's taking structure and using carbon storing materials. So these are systems that are meant to replace steel and concrete. They're very, very small bits of solid wood glued together in ways that allow them to span in multiple directions and act more like steel and concrete. This is an action shot of kind of a rector set of a large building that we designed for College of the Atlantic, a different one than one we saw earlier. This is a student housing building. It was all made of cross-laminated timber and glue-lam construction. Really exciting way to get kind of a lot of density of wood into the building quite quickly. They also have their own, Opal Build has their own proprietary standalone building system. So prefabricated panels that already come with the CLT and the wood fiber are already installed that can be erected quickly on site. This is an example of that. This was a field station laboratory that we designed for the Hurricane Island Foundation that was able to be erected from a barge with a crane on it because the island was inaccessible by car. So this became a perfect solution for unlocking a rural site. The entire thing was wood, except for the little steel clips that connect the wood together in certain cases. But here you see a 3.5-inch cross-laminated timber panel with 14 inches of wood fiber insulation on top of it that can just be craned directly into place. So it's an exciting way to use that material. And this was from the ribbon cutting of that field station lab. It was so close to the water based on the scallop research that they're trying to do that would actually had to be elevated 9 feet above the ground because of the FEMA regulations. But it was a really, really exciting project, even though it's so simple to kind of try out some of these technologies. So 2 quick case studies, and then we'll go to questions that are specifically around thinking about the way our thinking on whole life emissions has progressed over time. The first is one you saw earlier. This was like an early idea. It's like, could you look at an all wood passive house building and think about it in terms of whole life? We called this project All Wood All the Time, and it's one of our first cross-laminated timber projects. It's in Lake Warmog, Connecticut. And it was a very simple building that had to sit within this existing historic shell based on the zoning. And so we designed the entire thing in mass timber and then added the wood fiber insulation to the outside of it after the fact. And there was a predecessor of that kind of systems approach you just saw. We had the entire thing prefabricated at a mass timber manufacturing plant in Austria. They gave us these amazing drawings where it showed literally every part, exactly where it went. And that entire building was able to be erected in about a week on site instead of the usual length of time that would take. We're able to cut time from the install and the construction schedule, and also have this kind of just amazing, beautiful wood box finish. All wood on the outside too. We actually used heat treated wood, so it's unfinished, but it's incredibly durable because of the high heat exposure that it gets when it's manufactured. And we had a real all wood solution, and we were able to show how much storage we had in the building. So at this point, we weren't really measuring full whole life. It was early days in life cycle assessment, but we knew we had negative 25 tons of carbon in the cross-laminated timber, negative 19 tons of carbon in the wood fiber insulation, and negative 12 tons of carbon in the wood siding, stored solid carbon in the materials. And they were able to measure that against how much energy we were overproducing on the roof of the building, so we could start to pay down the overall carbon debt, since we noted we didn't have any debt from the wood, but we had emissions debt from space heating, plug lighting, all these other things. Oh, sorry, I can go back one. And use that to pay off the rest of the debt, that overproduction. Now we really took that to the next level with this project. Just finished, actually just had the ribbon cutting on Sunday. This is a dormitory for College of the Atlantic. And this is the first project where we've really been able to apply that full whole life assessment that that I just talked about, that I've been working on with the White House on a building, on a real building. So we don't have any finished photos of this, but it's an exciting project. Very simple dormitory on a existing disturbed site. So we weren't taking down forest or buildings to do it. It was already disturbed, a very small campus. 30 dorm rooms and 46 beds total, and then a common ground floor. We based the entire thing around the span criteria for those cross-laminated timber panels you saw, and set everything up like that. So we have this system that we knew we could work, almost like large-scale IKEA, and just ran through it. We took what's essentially this kind of modernist concept of what's called the maison domino from Le Corbusier, and thought about a mass timber structure that would work in that way. So very limited bearing walls. This is all just point-loaded systems. We had to develop some specialized details because there aren't a lot of buildings that use full mass timber yet, although it's a very exciting material. There aren't a lot of buildings out there that like that. So a lot of these ways that it connects with the other materials were custom, but luckily we had a client that was interested in being an early adopter for that. And the entire structure went up in about 3 weeks. We were able to top out from a slab to the top in about 3 weeks. Our Opal Build crew was the erection team on this. They put up the whole thing, and the president of the college actually got in on the act and helped install some of the hold downs on the building. Then we were able to apply the wood fiber insulation to the entire thing, so it got this envelope of nice warm wood fiber. In this case, all of the blown-in insulation is timber HP. It was one of the first projects, just like yours, Scott, to use timber HP in the entire world. And so all of the interior insulation was the blown-in timber HP. At that point in time, we weren't able to get the rigid board, but the rigid wood fiber came from Germany in this case. And then we were able to assess the entire thing in terms of its total impact. And right away, initially, we learned that when we're storing all of that carbon, at the end of life, what we call module C, it starts to give all that carbon back. And you can see in this red line the amount of negative storage we had within the building as part of that overall pie. But then I always wanted to kind of like look at that in terms of other systems. So we had that all mass timber system. There's also hybrid systems out there where people use mass timber deck and then steel beams. And then there's steel and concrete. So I actually made the structural engineer design all 3 versions, all 3 structural systems, so we could measure them against each other. And we learned that we were saving in storage about 40,000 kilograms of carbon emissions over time. And that's the equivalent to about 5.2 years of operational emissions, 0.7 years between the passive house and national average. So still going to a really low energy solution is a much greater impact. And just in terms of like life and things that we're used to every day, it's the equivalent of 7 cars off the road for 1 year, just changing those structural systems to something that's equally viable for this building. Once we added in the operational emissions, it dwarfed everything else. So, you know, in our region, because there's a high heating demand, operational emissions still rule the day, even at passive house level. They were over 50% of the overall emissions for the building. Luckily, we were able to offset that to get to net zero with PV on the roof of the building. So that was good. And then we're able to track with that overproduction on the roof, when would we get to zero across these 2 categories only? And for us in Maine, it would be about 63 years. If we exclude the energy so the emissions that aren't given off to another phase, it's about 45 years. But it was really interesting to us to look at it in other parts of the country. Like if we were to just move this exact same building to West Virginia, which has the dirtiest electrical grid in the country, it would have paid itself off. Like the overproduction of the photovoltaic panels would have paid off all of the embodied emissions in only 16 years. So you in Massachusetts are about halfway between those two. So this building in Massachusetts probably is about a 30-year payoff. Now, if we hadn't gone to passive house level in the operational emissions, we wouldn't have been able to overproduce in our PV, and so it never would have paid it off. It would have been impossible. So it's always important to start with that kind of operational emissions reduction. Then we started to think about it if we were to devalue it over time, because people do say, we are decarbonizing our grid faster than our resources are getting decarbonized. And even if we did that, still the operational emissions, that B6 number was the biggest chunk of the pie in the overall. And again, if we don't do the passive house assembly, they just overtake everything. Those operational emissions just become all of the impact and very, very negative. So starting with energy use reduction is very critical. Last thing we're going to talk about real quickly is that we have started measuring true whole life, as I've mentioned several times. And what that means is to think beyond just the energy use and the structure itself, but also be thinking about things like refrigerant leakage from the heat pumps that are super, super efficient, but that refrigerant that they leak over time actually has a much, much higher impact than carbon dioxide emissions on global warming. The impact of the mechanical systems themselves, and the impact of things like interiors and furniture. So we started measuring all of it, and then you start to see some interesting things, that the refrigerant and the operations are actually quite close to each other. So coming up with solutions to reduce the refrigerant was important. So in this building, we knew we wanted to attack that. So we had a custom heat pump system created where we actually put the heat pump coil inside the ventilation unit. This is our site super, intrepid site super Dave Harris fitting that custom coil on the roof of the building. And it allowed us to significantly reduce the volume of refrigerant, which took those emissions way, way down. And all of a sudden we were able to cut all of those refrigerant reductions out. It also made the mechanical systems much smaller, so we were able to cut more out there too. Now we're kind of in an aha moment, an actual pathway to zero emissions. So just some quick photos of the building prior to completion and move-in. Again, this is an all wood assembly, mass timber assembly, with wood siding on the outside, and right on the coast of Maine here in Bar Harbor. Thinking again about that pathway, how are those strategies actually working against that kind of carbon budget that I talked about earlier? Well, if we start with a conventional building, remember we have that target that I said that our group derived of 480 kg CO2 per meter squared. Well, a conventional building of this type, of this size, would be 3,400 kilograms of carbon dioxide emissions per meter squared, right? So that's a conventional dormitory. That's the same as 680 cars at an 8-year average lifespan, which is the current average lifespan of an automobile. So it's 680 cars, huge impact, not great, right? That's just a conventional building. They're getting built every day. So the first thing, as I said, that we did is we did passive house, right? We reduced the operational emissions, and that brought us down to 1,100 kg CO2 per meter squared. So we're down to only 235 cars, still not at that red line, that goal line. Then we did that refrigerant volume reduction that I just talked about. That cut out about another 200 kg CO2 of emissions, down to 187 cars. Again, still not there though. Then we switched to those biogenic carbon storing building system, structural systems that we talked about. We cut down another 100. We looked at reusing as much furniture as we possibly could from other dorms on campus. So we did that, brought it down again, little bit by little bit. Then those reduced mechanical systems, we did a passive house. That means we had way less mechanical systems. So we were bringing it down another little bit, down to 731. And then lastly, we put photovoltaic renewable energy production on the roof, which got us below the line. So these steps, and I wanted to go retroactively and measure the building appropriately against that whole life pathway to see, could we actually get below that drawdown pathway? And the answer was yes. If we do all of these things and design a building appropriately, so it's easy to do all these things, we can get below that target. And the interesting thing is that that was a 90% emissions reduction, which is really exciting. And if I actually look at the overproduction that they're going to achieve on site, we're net positive on site energy. That gets us down to 171. So we're not at zero yet. We can't get to zero today, except in really unique cases, but we can get really close. We can get to something that is on a pathway to zero as other parts of our industry decarbonize, something that's a huge net positive towards the planet, something that's well below our national target that the experts around the country like myself are setting, and something that's a 95% whole life emissions reduction and is the equivalent to 646 cars off the road today for the next 8 years. Super exciting. It was fun to kind of work through that. And I always leave with this quote that the problems of the world are increasingly complex, but the solutions remain embarrassingly simple. And really happy to have the chance to talk to you guys today. I'm open to answer any questions that you have this time.
Let me start by first saying I think the work you're doing is just very exciting in this day and age when we're thinking of climate as the crisis to instead be focusing on solutions is quite energizing. With that positive statement, I'd have to say for me to totally understand everything you presented would probably, I first thought would probably take a 4-year undergraduate program. Then I decided it would probably take a doctorate program. Given that, it was fortunate that I heard a short this is sort of ironic, a short presentation from the head of the White House Climate Policy Office yesterday.
Oh yeah, awesome.
And he was the guy that's the picture on the far right. I'm don't worry about it. What you mentioned his name.
Ali Zaidi.
Ali, that's right.
Right here.
Yes, he was the one. And what he really focused on was not new construction. Instead, what seemed to totally occupy his mind was all the buildings that currently exist and what were we going to do about it.
Yep.
I think he used the word moonshot.
Yeah.
How much do you, unless I missed it, it seemed like all that you guys are focusing on is new construction. How do you get involved in, to use simple words, upgrades, to use the same strategies that you talked about? And what's the balance? And well, let me respond to that. Then I have one more sub question.
Okay. So yeah, I think that we focus more on new construction mainly because of where we work. Our office is in a rural area, and we tend to, the clients that we attract on the architectural side, the design side, tend to be new construction clients. We have retrofit clients too, but there's just less of them because of the area that we're in. On the research side, absolutely involved with retrofit research. In fact, we've been involved with peer reviews of kind of theoretical thinking around the potentials of reduction in retrofit projects with Rocky Mountain Institute. That's one of my close collaborators. And so we work with them on sharing research around the potentials of those types of projects. And it's certainly near and dear to kind of what we're trying to focus on now when we think about things like circularity, right? The most circular thing you could do would be to reuse an entire building, right? And so we want to prioritize that when we can. Our architectural practice is driven by the clients that we have in our region, and so a lot of those aren't retrofit projects. We hope that there's more of those in the future, certainly, because it is an area that can be the lowest potential emissions for sure. And you can get into some potentially true negative scenarios there, which is exciting. So I'd answer that way. I'm curious about your follow-up too.
It's converting people, motivating people. I just totally agree with what you said early on about health being such a important factor.
Yeah.
But do you find in your business that primarily people come to you, or do you find ways to convert people?
Yeah, I mean, I think it depends on the audience. I think again, like it's a different audience with the advocacy and consulting than it is with the design, the architectural design. Architectural design is still mostly, say, probably 80% a referral-based client acquisition process. So these days, because we're a national leader in sustainable design, we're often now getting pre-converted people coming to us because they know what we do. That it wasn't always the case though. So what we were trying to do at the beginning of the practice, before we were focusing on whole life emissions, was to just show people, usually with bringing them to kind of our, case study building, the one that we built at our venture capital, how comfortable and great and beautiful these zero energy buildings could be, right? So we were doing that kind of social comparison through example before we even knew, based on research, that was the biggest motivator. It's like it was always easier to convince people to just show them, right? Right? Like show them how beautiful it is, show them how comfortable it is, show them how little mechanical systems there were, and maybe also show them the energy bill that was like nothing, and that was what we were starting to do even way back 10, 15 years ago. Now it's less of that, honestly. On that side, the advocacy side, it's you do get a broader cohort, people that are in different points in their learning process and maybe even in their convert process. And we're always looking for new ways of thinking about how you motivate those people. And I've found that, the big reason I created that framework, to your point about community health, is that everybody has an in somewhere. Even the most adamant deniers, they don't like that their buildings might have too much CO2 in them, or that they're falling asleep or something like that. There's ways in for everyone, and you can start to show examples of how that doesn't have to be the case. And we found that really does work. It's kind of crazy, but it does work when people are able to see those examples.
That's that's encouraging too. I know you've got questions in the chat, so I shouldn't take up more of your time.
Thanks, Andrew.
Well, Tim, we really appreciate your presentation tonight, because that's a huge help. There are a number of questions that have been posed over time that from our CFE group and things that I've been aware of, and then we'll get to a couple other questions. One of the talk about defining language. One of the things is measurement, and one of the problematic things in talking to manufacturers, as we've been doing this new house, and I wanted to measure things on all levels, was what I call the nutrition label concept. And in talking with a lot of the manufacturers, they sort of poo-poo the idea by the idea that, well, it's different transportation one day in, it's different transportation by region and out. And so it's very hard to get a standard that somebody can grasp and get their hands around and be looking at it and saying, what is really the way to measure going forward for carbon? Do you have any thoughts on that of approach to that,
Yeah,
getting around that issue?
I think it's getting there. I mean, I think that we have to all remember that, especially around whole life emissions, this is a really young field of study, and we're still coming to common methodology. Like that's work that's happening every day, but we are getting better to understand what a good EPD or environmental product declaration is, and make sure they're standardized and people can understand if it's been appropriately done. I think one thing people don't really know about nutrition labels, even on food, is that it doesn't mean that exact thing has exactly that nutritional content. Usually there's about a 10% variance from batch to batch, product to product, and that's accepted, because what you're really trying to do is hit the median, right, or the average. And it's the same with EPDs. Yes, does the exact emissions change little by little over time or day to day? 100%. But if you know that you're hitting the median, then we have a confidence scientifically that we're accurate, right? And we can use that in a formula. And so I think it's not quite there yet, it's getting there. And there are people that totally agree, and that's why there's a lot of effort that certain people put into that product side, the EPD side, and trying to make that consistent so that it is an accurate nutrition label across all products. And it's getting better, it absolutely is. But it's also kind of learning, and it's building the plane as you fly it a little bit. I'm not gonna lie about that, but agree, and we're getting there, is what I'd say.
Greta made the comment that on here that that your comment about greenhouse gas emissions is a much better discussion point than carbon. And where do you find the thought process at this point in moving towards emissions in the dialogue as a discussion point as opposed to carbon, which seems to be, as I've been talking to people, nobody understands carbon. They understand the word emissions, I guess, is the.
Well, honestly, like, this was how the White House educated us. Like, when we got involved last year, they said we use the word emissions, and they use the word emissions because it pulls better, right, across the US, because nobody, doesn't matter what your political proclivities are, like, nobody wants, emissions seem bad. Like, you don't want to breathe in, nobody wants to breathe in emissions, right? Even though we're talking about carbon dioxide emissions, that's not really the problem we're talking about, but it didn't matter, right? Like, it's like, okay, they mean the same thing, because when we say CO2e, we're saying carbon dioxide equivalent emissions anyway. And carbon's confusing because carbon isn't even what we were ever talking about. We're already using that as a shorthand for carbon dioxide emissions. So using the word emissions instead of the first part of that phraseology was like an aha moment, even for us as experts. We're like, oh, duh, like, we should have been doing that the whole time. So that was how we learned from the politicians. And I think it actually is just more accurate too. And so it was a good kind of aha moment. We're trying to do our best as practitioners to normalize that. But which takes time too for us. But yeah, language is so critical. Like, the words we use carry a lot of weight, and they can carry a lot of baggage, and getting away from those types of terminologies is really important.
And I think one of the things that, has been raised in several of the questions and in lots of conversations, including any phone calls that I made today to the local city council members of the city where I'm currently living before we moved to Lincoln, was they just voted to basically amend the 10 town pilot and allow move towards the direction of allowing gas stoves in new construction and in retrofits, which is a major step backwards. And I have to have a shout out to Marcia Cooper, who's on tonight, who's president of Green Newton, an organization that's been around for 30 years, Marcia, for the advocacy that has pushed things forward in a very positive direction. But I think one of the things, as how do you train more architects, engineers, and contractors to be aware of these issues, and how do you bring costs to a point where you can measure and you can have the incremental cost be at a level that people can actually afford in housing, as opposed to an institution where they can go out and get lots of donations and build a fabulous building?
Yeah, I mean, I think that, the first step is, you already said it in the previous question, it's like getting common language and common terminology and common example projects is always the first step. I mean, we're designers, so we think about things visually. And so when we have visual props that we can share and they're beautiful, that's always a great first step for anyone, because a client, a builder, another designer are all going to gravitate around something that they see as a visual success. And that's always great. The other thing that we try to do, I think myself and even my other colleagues that I work with across the country at this level, are always trying to be as open source as we can and share and learn and be open to being wrong with each other. so that when we go out and communicate to those that may not know as much or are learning, or they're somewhere else on that trajectory, that we're being honest about what we've learned. It's why I showed you a project that we originally thought was actually carbon negative, that now when we measure whole life, we realize isn't. It's important to do that work so that you know what other things have to be done, and then share it and say, you know, look, we're learning too. You can learn on this pathway. The other thing that's cool right now is that a lot of these things like carbon storage in wood materials is really popular. So people are excited and they like want to use these things. And then, oh, by the way, they're also like really great for the environment. Like that's a really easy way to bring people's education up much, much faster, even people that might have been resistant in the first place. I think that advocacy is just time and discussions like these, and just being really open with that time with people. I know myself and my colleagues really believe in that, and it's an important part of our work and our daily practice.
Well, the most exciting thing that I think people comment upon walking through this house as we're going through this is a net zero passive house that is just being finished is Timber HP. What's amazing is the number of people. It stops everybody in their tracks, and they have questions and so forth. So that's been very rewarding to see. A couple of questions. Roy asked a question that Roy always asks great questions. I'm always impressed with Roy's questions. Maine and Massachusetts are on the same ISO New England grid. Why are Maine's emissions only half of Massachusetts?
It's the profile of the percentage of production from different sources is different, even though it's on the same grid. And we use those. We understand that the grids are connected and that it's not actually exactly different like that. But the reason that we show that is that when you're building a project, you're buying into a collective decision to purchase power in a specific way that's made at the state level. And so you need to be making decisions around that. And that's reported every year. And even though that's not literally physically what's happening because the grids are connected, it is, again, it's that kind of median question. Like you're either pushing that up or pushing that down, and you can have more or less impact based on how that power is being purchased, whether it's literally that kilowatt that's going to you or going to somewhere else in New England. It's kind of irrelevant because that all makes up to this matrix. We think that's important because it makes people aware of how their power is being bought by the state public utility. Now, it's even more relevant when you move regions, right? Because there's areas of the country where it's radically different, right? And New England's better than most by a long shot, but it's really important, I think, for people to understand that even though it's all connected, those deals are being made in different ways and they're contributing in one way or another. So if you can draw that down, that's helpful. But yes, we understand that they're not literally different in that way, kilowatt to kilowatt everywhere.
Well, one of the fascinating things that we ran a discussion a couple weeks ago on demand response, and one of the things we talk about the makeup. I'm a huge believer in demand response and the ability to cut off the top of that curve, which is the dirty, and very expensive power production with people's storage of batteries and sweet batteries and so forth. So I urge people to go back and watch that one if you're interested. I think it's a wonderful thing, and the costs are coming in line. A couple other questions. Greta asked two questions. How do you account for durability or service life in measuring embodied emissions?
Yeah, so I'll just show this chart while I talk through it. Whole life emissions, what I always talk about whole life when I'm talking about a complex thing like a building. Scott Johnson from Timber HP, who's on right now, he's making products. So he's only going to really be thinking about a product stage. Sorry, Scott, I called you out. I can see you there. But when we're looking at buildings that have thousands of products, we want to look at the whole thing. And one of those life stages is use, right? So what you do is you take all of the materials of the same type that are made across the entire region, and you assess typically on average how long they last. And then you set that as a replacement period. So when we do a whole life assessment for whole life emissions, we set the typical, the accepted, agreed upon range that you measure is 60 years. Don't ask me exactly how we came around 60 years because I don't know, but that's the range that we use. And so you just are looking at, on average, how many times you have to replace that specific material in 60 years. And if you have to replace it, you have to account for that product phase again, right? And you do that on 1,000 different products. Now, luckily, we have software because we can draw in 3D now and assign masses to things in our software. It'll do that automatically. So it just sorts through all of the products in the building and reports it. But that's literally what's happening. There's certain things that can't get sorted and I have to do it by hand, which sucks. But so hopefully at some point we'll have all of the products available and we can do that all automatically. But that's how you do it. It's just an average, for each
And
material.
you included maintenance as well, which I found fascinating is in
Absolutely.
part of that question that Greta raised. But one of the things I think would be wonderful is also having a session sometime on Zoom going through for those who want more for detail is literally what the modeling looks like, because I think that's teaching people how to model for between contractors, engineers, architects, etc. It would be fascinating. And the lessons learned. I went through the BU Computer Center the other day, which is an amazing building, but a lot of lessons learned, that some of them challenging with especially with geothermal.
Yeah, absolutely. Yeah.
One other question, and this is a question that involves Scott also. Scott's one of my favorite people in the world.
Mine too.
How does the wood fiber insulation meet building code requirements for fire resistance? And I'm going to add moisture and all the other things to that, and bugs, because I think those are important discussion points as well.
Well, I'll let Scott. Scott, you want to answer?
That's just shameless. Thank you. You two are so kind, so kind. And I enjoy thoroughly working with you two as well. Incredible intellect. Learn a lot all the time. So yeah, it's funny when you put wood fiber in front of some folks, they immediately are like, well, that's just gonna spontaneously combust, of course. It's like, well, what are you building with? You're framing with what? Well, I use wood framing, I use wood sheathing, I use wood decking. I go, okay. I get the fact that it's absolutely more refined, and I can see that reason why they think that. But of course, we have to build the code, right? So what we do is we are integrating for the two interior products, which is what Scott has, some wood fiber, which we call timber fill, and then also he's using some timber bat as well. And both of those products, when we actually start to process that wood, we steam them, and as we're shredding that wood fiber, we're immersing that in a liquid borate. And that liquid borate, it's just a wonderful non-toxic material, naturally found here, abundant all over the world, deposits everywhere. And it's been used for years upon years. In fact, if I say borax, I bet there's some people on this call that might remember that. It's been used for years in the building material industry to stave off decay, rot, etc. So it's got three uses for us. One is, first and foremost, is the fire. So it's a fire retarder. Okay, that allows us to get to the code requirements in single family homes and even up into light commercial and the like. Then the other really cool thing about it is, if you think about a storm that blows through and we've got a tree limb that comes in and exposes a wall, and part of that segment of that home is damaged. What's interesting is, if that wood fiber actually gets wet, that borate, and let's say it's now, perhaps if it was raw wood, it might actually start to get mold, if you will. The borate mitigates any mold growth on that. So if parts of that wall need to be redone, but some of that wood fiber that got wet, whether that was a timber bat or a timber fill, that material can dry out and still be viable. And then thirdly, insects do not like to eat it. The sugar component that's in that material will kill them. So fire, bugs, and water. So it's a pretty wonderful material for us to use. Hopefully that answers the question for you.
I'm just going to add one thing. I'm going to add one thing, Scott. Sorry. So
Sure.
this building right here, which again, as I said,
I know where you're going. It's wonderful.
I know. It's good. Just won National Design Award on Friday. During construction of this building, we're putting all the wood fiber, one of the first buildings to use wood fiber in the US. And I don't know, Scott, maybe still one of the biggest, maybe the biggest. I don't know. It's possible. That we had all the rigid insulation. There was a pile of waste scraps from cutting up the insulation to put on the building that were sitting outside, neatly stacked near the compressors that were being installed for the building. A worker left a propane tank on, a portable propane tank, left for the day. The tank exploded and caught one of the compressors on fire, one of the VRF refrigerant compressors on fire, which was right next to this pile of wood fiber. Wood fiber smoked and never caught fire. And the volunteer fire department, of which the president of the college was part, came and just buried it on site. It never caught fire. It was sitting right next to it. And I get this frantic call. It was on a Sunday night from Darren, who is the president. He's like, "There's a fire on site." And I was like, "Really?" He's like, "Yeah, but you're going to be so excited. The wood fiber didn't catch fire." So, all these things that we learned in theory were true in reality. And yeah, there's immense scale is possible with these materials. Scott talked about the technical, but that's the personal right there.
And I think you
Well, it's
mentioned it.
also,
I'll say just one other thing. You may have glossed over it, and I'll just be 2 seconds. Tim, you and Opal have been early adopters of wood fiber, and just to reiterate, this is 25 to 30 years of manufacturing in Europe. So you talk about skeptics, here in the Northeast particularly, and that story. And there's like 10 different manufacturers. I'll spare you all the details because it's late, but nonetheless, it really proves out the fact as you bring it over to the United States, it's like they've been using this for 25 to 30 years.
Yep.
It's viable.
Not new.
It works.
and that's actually one of the interesting lessons that we've learned with this process of this house where I'm sitting in right now. That's not, it's not quite finished, but there's the process that there's so many things that we brought that were lessons learned in Europe that the Europeans are far ahead of us, whether it's window technology or on other things. And so part of the thing that I keep looking at is it's an integrated concept with all this between the insulation, the windows, the water. We're using things like, touchless faucets that use a lot less water as a result of the fact you're not just turning it on. And then things like load management for the electric becomes much more important. So all of these things have to integrate to come up to the right answers. So it's vital that we all learn. And, it's organizations like Marcia's with Green Newton that's educating people and has been for a long time. And we need more and more and more of those. And we're very lucky in Massachusetts to have an awful lot of people who are great volunteers and doing great work. And Belinda's been doing an amazing job in Lincoln for a long time and the surrounding communities. And so we're very any other questions tonight that anybody want to step up and raise a question? Please unmute and go ahead and raise a question if you have it. All right, no further questions. Tim, I can't thank you enough and for your time tonight. We'll post this on, it will go on YouTube tomorrow or tonight by Belinda. And we hope we get a lot more people watching and learning and educating themselves as we go forward on it. And I thank you for the work you're doing for the White House and for all of us as a result.
Well, thank you so much for having me. Really appreciate it, and a lot of great questions, which is awesome. Really educated group, so that's cool. Thanks, Scott.
Have a good
See you,
night.
Scott.
Thank you,
See you,
everybody,
Tim.
for
Thank
joining
you.
us.
Nice to see you, everybody.
Bye-bye.